Yeah, let's do some math. So anyway, what I want to talk about, Jackie, turn around, is there are some problems that become challenging to solve. So I'm going to show you something that you'll probably just go, I don't know what to do with this. So let's say I have the square root of 2 and I want to multiply it by the cube root of 4. And I can't do anything the way that they're written because they don't match. So it's kind of like the roots have to match in order for me to do anything with what's underneath the roots. So we came up with a new way of expressing these problems so that there would be something we could do. Okay? And that's going to be lesson 7.3 called a fractional, or they say in our book, rational, which is a fancy word for fractional exponents. So we're 318. So this is how it works. First, you want to identify the exponent on your base. And you want to make sure that your base is simplified, meaning that if I could write it a different way, then I want to try to write it a different way. Now, 2 is just 2. So what's the exponent that's on the 2? What's the exponent on the 2?
1.
Yeah, if I don't see it, it's 1. Now, you don't see the root number, but I called it a square root. So what root are we taking this to?
1.
Okay, in the crook. What would go in the crook?
Oh, 2.
A 2. Okay. So if I want to write this and I don't want the radical sign, I write the base. The exponent on the base is the numerator. The root I'm raising it to, or I'm not raising it to, but trying to take it to, goes in the denominator. So the square root of 2 is the same thing as saying 2 to the half power. Okay? Now, 4 isn't simplified. What's another way that I could write 4? What is it? Yeah. So I could write this as the cube root, of 2 squared. Okay? So I'm going to do this same idea that I just did with this one. So I have a base of 2. What's the exponent on the 2? 2. What's the root that I'm taking this to? A 3. So now what I have is 2 to the 1/2 power times 2 to the 2/3 power. Now, if I'm multiplying and the bases are the same, what am I going to do with the exponents? What am I going to do? I'm going to add them. Okay. So then we run into the problem with fractions. So what do we need in order to add or subtract fractions? We need a common denominator. So what's the common denominator for 2 and 3? 6. So here, I multiplied top and bottom by 3, giving me a new numerator of 3. And on the other one, I needed to multiply top and bottom by 2, giving me a new numerator of 4. Okay? And then I can do the math. And I get 2 to the 7/6 power. Okay? Now, here's what's kind of strange, is we're going to be talking about this idea, but a lot of the math that it involves isn't necessarily covered in this class. So, but they still want us to teach this, so we're going to teach it. All right, well, what does 2 to the 7/6 power look like? Yeah, well, let's investigate on that one. So what I can do is rewrite it back in radical form, going backwards with that fractional exponent. Okay? So what's the exponent that attaches to the 2?
7.
The 7. And what root are we taking this to? 6. Okay. Now, the 6th power says I need 6 of the same thing in order to take it outside. Okay? So again, this is the part that we aren't really covering. They've taken radicals out of our curriculum, and we're not covering, but this is the reality. If I want to take the 6th root of something, then I have to have 6 of that thing. Do I have 6 2's? Yeah, in fact, I have more than 6 2's. So what I'm going to do is rewrite 2 to the 7th into 2 parts. I'm going to write it as 2 to the 6th power. And how many 2's are left over? 1. Because remember, when I multiply and the bases are the same, I would add the exponents. Okay? So we're going to take 2 and 2. We're going to take them each to the 6th power. We have a 6 here. We have a 1 here. So how we can take a root is if my index, which is the number here in the crook, matches the number that's here, this guy can come out. It's like the key that gets him out of jail. Okay? So when these two match, he comes out. So this becomes, 2. Does this key match this key? No. So guess what? He's still in jail. That's the way it goes. So we would write 2 times the 6th root of 2. And that would be the answer. Okay? So that's a lot of where this is eventually going to go. But what we're going to be practicing is this notion of fractional exponents, how to break something down so that we can see if we can take a root. But the key is if the index and the exponent under the radical match, I can pull the base out. So I'm going to write that down. If the index, that's what root, and the exponent on the base under the radical, match, then the base comes outside with no, no exponent. Okay. So let's talk about this. Let's do a couple of them that would work for us. How about the 5th root of 32? So 32, I have 1 of them. I can't take out 132 because I would need 5 of them to take out the 32. So is there a better way of writing 32 so that maybe I'll have 5 of the same thing? So let's start thinking about what are factors of 32. 2 and? Okay. Do you guys remember doing this, prime factorization? Okay, let's simplify 16. What 2 factors 16? 8 and 2, okay. What about 8? 4 and 2. What about 4? 2 and 2. So let's see what we came up with all together. So I have the 5th root of, 2. That shows up 1, 2, 3, 4, 5 times. So the index is 5. The exponent on the base is 5. So what's the answer to this?
2.
The answer is simply 2.
Oh, I get it.
Okay?
What? No.
So when the index, that's the number in the crook of the radical, and the exponent on the base match, the base comes out. Done.
So it means it's 2.
The answer is 2. Yeah, magic, huh?
So you'd get the 2 that's in the second one?
Yeah, because I've rewritten 32 is no longer 32. It's now 2 to the 5th power.
Oh, and then, okay.
Okay.
That makes sense.
All right, let's try another one similar to this one.
Weird, actually. Wait, so the 2 5s cancel out each other? Yes.
Yes, they do.
Oh, I get it now.
So if I want to take the 5th root of something to the 5th power, I get that something.
But what if it was a 6?
Then there would be one left behind. I can only take out multiples of 5. So if I have anything beyond 5, it would stay behind under the radical sign. Okay? So let's look at this one. So I can't take the cube root of 27 because I only have one of them. So is there a different way to rewrite 27? So let's prime factor. So we get, oh, man, when he gets it, he gets it. So 27 is 3 times 9. 9 is 3 times 3. So we get the cube root of 3 cubed.
It's 3. It's 3.
The index and the exponent match. 3 comes out.
Wow. What if it doesn't match?
Okay. Let's do one that doesn't match. What if I asked you, we'll just kind of take off on that one there. What if I ask you for the cube root of 81? Okay. So we start with prime factorization to see, because I only have 181. I need 3 of something. So I have 9 times 9, but that's only 2 9s, so I'm going to keep breaking down. So that's a 3, 3, 3, 3. So what I end up with is the cube root of 3 to the 4th power. Now, what I need is 3 3s in order to take a cube root. Do I have 3 3s?
Yes.
Yeah, in fact, I have more than 3 3s. Okay? So I could break this into 2 parts.
3 to the 3rd.
3 cubed, because that's the one I want, but then I have one more 3 left over. So I take the cube root of 3 cubed, and then I have the cubed root of 3. So what's the cube root of 3 cubed?
3 times.
Just 3. And then I have the cube root of 3 that's left over. So we would call this like a mixed answer. Like we can get a mixed number with a whole number part and a fractional part. We can do the same thing here. Okay? All right, let me show you maybe a slightly different way that will help you see it a little better. Let's go from here, and let's rewrite this without the radical, but as a fractional exponent. So the base is 3. What's the numerator? 4. What's the denominator? 3. Okay? That's an improper fraction. Can I rewrite that as a mixed number?
Yes.
What would I get? I'd have 3 to the 1 and 1/3 power. So what that says is I can break this into 2 parts now. I have 3 to the 1st power times 3 to the 1/3 power. Well, how do I write 3 to the 1st power? I write it as 3. How can I rewrite 3 to the 1/3 power without the fractional exponent?
Radical sign 3 under the radical and 3 as the index.
Yep, the index would be 3. Same exact answer. So if I get an improper fraction, I can write it as a mixed number. The whole number part of that mixed number gets attached to my base, and that's what comes out. The fractional part of my remainder says I still have something left under a radical. So I get 2 parts to my answer. I get a whole number part, and I get a radical part. Okay? So let's talk about the 2 most important ones that they want you to understand. Okay? The 2 most important ones they want you to understand. The most important one is the half power. So anything to the half power, how would you rewrite that using a radical sign? Yeah, B, just any generic letter. do we write the 2 in, it's called an index, so thingy doesn't really help.
2 in the index.
Okay. So
In the middle.
it would look like this, but we actually don't ever write it inside the index as 2. If there is nothing written, we know it means square root. So 1/2 power means the square root of. So the relationship can go back and forth. I can write from the square root of b is b to the 1/2 power, and I can write b to the 1/2 power is the same thing as the square root of b. Okay? And then the other one that they like you to deal with, they call them the nth roots. The nth roots. They said, again, if we have b to the nth power, let's see how to say this. I don't like how they write it. Let's do it this way. I think it's easier if we do it like this. So my index is n. What's my exponent on the b? 1. So we could write this as 1 over n. Okay, so I can take any power that I want. The reality is we're going to try to simplify the base as much as we can. So let's write that down. Simplify the base. As much as possible. Using prime factorization. I think prime factorization is one of the most useful tools from earlier grades because you can use it for so many things, Okay. Let's see. So let's look at what kind of numbers that you're going to have to deal with in your homework. So let's do some examples, and I'm going to do some of the problems that show up on homework. And we're going to do this really simply because, again, and I love teaching this unit about radicals, but for some reason the high school has now taken it and put it into their Algebra 2 class. So that's fine. But they just need you to be familiar enough with what does this exponent mean when it's a fraction. That's really what they're looking for. So here's a couple of examples. Directions are going to ask you to express in radical form, or I'll say write in radical form. So that means put that radical sign back in, or in exponential form, that means your exponent, exponential form, will be written as a fraction. So it depends on how the problem's given to you, what you're going to give back. So, first one. Actually, let's do 24 to the half power. So how would you write that? Since it's with an exponent, how would we write it with a radical? Morgan.
You have 2 as the input.
Okay.
24 is the radical.
And that would be it.
Wait, because 1/2 means square root.
Okay, because we've got 124 and we're taking the square root of it. That's the 2 tells us what root to take it to.
So if you wrote it with the 2 in the index,
You would never see that written that way because the square root is the symbol without any number written in. Okay? Philip.
But if we wrote it like that on the test, would we find the answer?
I would take off some points because we don't write it like that. You got to learn how to do it properly.
What if there was like a mixed number?
Okay, well, we'll get there, but we're not there. Okay, I don't think they're going to ask you too many of those. Okay, I just gave you worst case scenario of what we were doing. Let's do another one. Let's go the other direction. Let's do, this is it. Actually, let's do this one before we do the other kind. What if I have a fractional exponent and that exponent is attached to parentheses? How would I write that now in radical form?
Same thing.
What would it look like?
Oh. It would be y inside the radical, and then
just the sign,
Mm-hmm.
and then times 12 in the radical.
Is it a different radical?
No.
So it's the same.
Yeah, it is different.
So you're saying I would write it like this?
Yeah.
Okay. I think we can do it a little bit more neatly than that. Michael?
So you do 2 in the index and then 12y in that.
So remember, if it's a 2 in the index, we don't need to write it.
Yeah.
So we actually can write it just as the whole thing, 12y, under the radical. Okay? All right, let's try another direction. Let's do this. Oh my goodness. Now, as much as I would like to simplify things, you actually are not going to be required to do that on your homework tonight. Because see, again, I love this chapter, but we don't get to teach the chapter that I love. So this is asking you, it's given to you in radical form. How would you write it in exponential form? How many 44s do I have? How many 44s? 1. What root? Done. That's it. Okay?
Wait, how'd you get that?
There was 144, and the index was 2.
Oh.
Okay? So let's write down a little note to ourselves on that. This was the exponent on the base. Oops, sorry. That's the weirdest N I've ever written. And by the way, they call the base a radicand. So just throw that vocab at you. Radicand. The 2 is the index of the root. Okay? And that's always where the fraction comes from. Okay? Now, when you hear the word simplify, so now we're changing what we're going to do. This is when you're going to do the prime factorization. Oh, simply. That's not the word. Simplify. Okay, so number 4. And I got to be honest with you, you've got some ugly numbers here. So you're going to have to really push yourself to see what is going to work. So this one has something to the 5th power, or the 5th root, and I've got the number 1024. So let's start with what we think it could be. So what can go into 1024? So we got a 2 and a 512. Okay?
How'd you know that? Who said that?
Because she's smart. Okay?
Who said that?
But that's not good. We got to keep going because we still have this guy. So what goes into 512? Shh. 2 and 256. Up, we can still do prime factorization on the 256. What about this one?
28. What? Oh, 2 times 28.
2? What?
No, 2 and 28. 2 and
No.
28.
That's all right.
Oh, wait, no. I'm thinking of something.
No.
I thought it was 56.
128 might work. Okay, up. What can go into the 128? 2. So we get 64. Oh, now you guys are really causing me problems here.
8 times 8, 4 times 2.
Okay, hold on.
2 times 2.
I've got 4 times 2, 4 times 2, 2 times 2, 2 times 2. Okay? Wow. Okay, so let's see what all of that is.
3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So we ended up with 10.
2 to the 10? Wow.
Okay, now, to help us, now, first off, we look at that exponent. Can 5 go evenly into that exponent? Yes, so that means everything's going to come outside. So that's the cool thing. So what I can do is turn it into a fractional exponent, where it's the numerator on the base, or the radicand, divided by the root. And what's 10 divided by 5? 2. So I get 2 squared. Now, what does 2 squared equal? you have to go as simplify means do all the math you can do until there's no more math to be done. Now, here's the trick. 1024 is really 4 to the 5th power. That was a different way to do it. But you guys went with the 2, so that worked. We still got the answer.
So like,
Okay?
what's the answer? Is that like
The answer is
4?
4.
I know, but
That's why it's boxed.
Oh my
No,
goodness.
no, I know that. But what is it the answer to?
The 5th root of
That's what I'm
1024.
trying to figure out.
No, we started, see, equals. So we started with the 5,000, or 5th root of 1024, and we ended up with 4.
Okay.
Because there was 4 to the 5th power. Taking the 5th root of that gives me the 4. 2 to the 10th power, taking the 5th root of that gives me 2 squared, which equals 4.
Are all the numbers going to be like that?
No, not all of them. Just some
Not
of them.
test.
Just some of them.
Probably Michael.
All right, let's try another one. Let's try one that's a little bit more. Okay. How about, let's see, is that number 5? Yeah.
2 million to,
What if I have a problem that looks like this? $49 to the 5 halves power.
You put it in a bracket.
Okay. So we have a couple options. We can try to figure out how many 49s we have, see if we have enough. What kind of exponent do we have?
It's 2. No, we have a fractional exponent.
Yeah, we do, but what kind of fractional exponent?
Improper.
Improper fractions. So what we could do is try to write this as a mixed number, okay? So we could say that's 49 to the 2 and 1/2 power. So the whole number exponent is what goes on the 49. We also have 49 to the half power. So we're going to have to figure out what 49 squared is. Now, before I do that, let's rewrite 49 to the half power as a radical. So what would it look like? How about I write 49 to the half power as a radical?
It's just 49.
Radical 49.
That's right.
Okay? So, wait a second. Don't we know what the square root of 49 is?
Yes.
It's 7. So what we end up with is 49 squared times 7. Now here's the unfortunate thing. You actually have to figure out that answer. I know. How horrible is that? Are you eating a plastic?
I'm not eating it. I went like this.
Okay.
No, like this.
He brought toys with him to class
No, it's for a project.
today.
Come on, it's for his project. Let's get a good grade.
Okay. All right, let's multiply 49 times 49. We get 81. 36 and 8 is 44. Placeholder. 4 times 9 is 36. Sorry. We get 16 and 3 is 19. Shh. We get 2,000, or 2,401. But now we have to multiply that answer by 7. And that would be your final answer. Okay? It's called multiplication. You learned about it back in 3rd grade, so I think we should be proficient with that part of it. Now, let me show you an alternative. Let's simplify 49. What's another way of writing 49?
7 times 7.
Okay, now remember, this is being raised to the 5 halves power. So I could write it as 7 squared, right? 7 times 7. What am I supposed to do when I'm raising a power to a power? What do I do with the exponents? I multiply them. So the 2's cancel, leaving me with 7 to the 5th power. 7 to the 5th power actually works out to be 16,807.
Did you leave it like that?
Nope.
It says simplify, Michael.
Yeah, simplify says do all the math that you can do until there's no more math to be done. Okay, I already dealt with one tantrum this morning, so I don't really need to deal with another one in class. Thank you very much. Let's see. Yep, so that's what you get to work on. Some of the problems are going to be very simple, and some, maybe not so much today, but tomorrow or Monday are going to be a little bit more complicated.